Welcome to MEI Modelling with Algorithms. We're on the topic Linear Programming 4, Further Network Problems, and this is video 4.2, Allocation Problems. So if you remember, allocation problems are very similar to matching problems. The difference is though that instead of it just being a yes or no thing, whether that matching is possible or not, each association has a cost associated with it. So it might be a financial cost, or it might be the time that it's going to take, or something like that. So here we have a table now showing the costs, possibly the time for each association. So we could imagine that we've got 4 workers here, for example, 4 tasks. Any worker can be assigned to any task, but some workers are quicker at some tasks than others. So each number is representing the time that worker takes to do that particular task. So what we need to try to do then is to minimize the total cost, total time perhaps, for this. What we mean here by a maximal matching is that each worker is assigned exactly one task. So just like before, we'll introduce variables for each possible association, and we'll call these A1 and etc. just like before. And because we're considering each possible association here, we've got 16 variables in total. Now the worker either does that task or they don't, so this will take a value of 1 if it's going to be included, or 0 if it's not going to be included. And so the thing that we want to minimize is the weighted sum of all the variables. So for example, if we were thinking of including this association here, that would be the variable A2 would take a value of 1. That would be multiplied by the cost for that task, which is 2. Alright, so what we need to minimize is this. Obviously 5, because variable A1 has a weight of 5, so 5 times A1, and then plus 2 times A2, and so on. So multiplying each variable by its associated weight, and finishing with the final one, which would be 6 times D4. And now we think about constraints. What we know, of course, is that it's a maximal matching, so each of these is going to be assigned to one of these. So again, we can only have 1. In fact, we will have exactly 1 in each row and exactly 1 from each column. So for example, we could say that A1 plus A2 and so on to A4, that must have a total of 1. Alright, and then we'll do the same thing for B1, B2, B3, and also the same for A1, B1, C1, D1. So there'll be a total of 8 constraints there in the end. So to summarize that then, the thing that we want to minimize is that, and the constraints are these 8 here. And we have the condition as well that the variables are binary, so they're either 1 or 0. So here's the solution from our LP solver. We can see it's told us that the total cost for the solution that it's found is 6, and the solution itself we can see by looking at where these 1s appear. These tell us the matchings which have been included. So on our table we can see them. So it's told us to include B1, which is there, A2, which which is here, C4, and D3. So again, notice it's done, it's obviously worked because we've got exactly one from each row and exactly one in each column, so that is because we put in the constraints, and it's managed to find a very small total, a total of 6 there by finding those 4 values. So that concludes video 4.2, allocation problems. The next video will be 4.3, transportation problems.